Okay, Assalamualaikum and a very good afternoon. Okay, so now we proceed to the linear programming methods. Okay, how can we solve instead of having graphical methods or by QM for Windows, for example, software. Now we are trying to look at what happen if we have a lot more constraint for us to consider in the uh, our problems in hand. Okay, it's either you have a different type of constraint or you have different type of inputs for you to look into your original problem. Okay, so in this case, we are using simplex method. Okay, but let me remind you also, this simplex method actually, this is how the simplex method works. But you can always transfer once you get the information and the knowledge from this particular method. You can always transfer this and solving it by using a machine as well. Okay, so for the time being, you need to know the behind the operation behind the simplex method. All right, so we start with the concept. All right, these are the steps. Okay, so if let's say you want to remind again yourself, once you go in all the steps later on, you need to remind again what is it that you want to solve from the first one until the seven steps. These are all the steps I laid out earlier. Okay, so in case you get a little bit confused, you can come back to this page 65. All right. Okay, so now I just proceed to the problems. Okay, you can read this one in your leisure time. Okay, the example. Now, we have a company, and then this company produce tables and chairs. Okay, and then it give a lot of different constraint and a lot of different coefficient, for example, because right in our mind we have to always keep on remember, if you have statements like problem, you need to really scrutinize and extract all the information that you are given into a mathematical form, a table form, or whatever form that is easier for you to digest and for you to uh, construct the solutions. All right, so in this case, you identify your variable now is in the sense of tables and chairs, and then the constraint. Okay, there are labors. Okay, hours of labor. Okay, in the carpentry departments, and then hours of labor in the finishing department, and then there are other constraint, the hours spent, the available hours spent, and then the available hours also spent for the finishing time as well as for carpentry time. Okay, and then by the end of the day, you know that one particular table will give you a profit of 70 ringgit, and then a profit of a chair is 50 ringgit. So your problem is to find which type, how many chairs you need to get, okay, produce, how many tables to produce, okay, for you to get the maximum profit that you may able to get. All right, so that is the main problems in this sorry, in this case. So in this case, these are examples, and then you know from all the problems, if you have a very complicated problems, for example, okay, as long as you can extract the information and as long as you can translate it into a table form, then you can always find a solution by using the simplex methods. All right, why? Because the concept is just the same. You have those seven steps I put earlier in the previous slides. How you're going to do it until you get the final version of your profit making, the best profit making, always the same. Okay, it's just that you need to keep on repeating your steps. So the first step is okay, and then the next step should be okay. The problem with simplex method, for example, if let's say you are using your own piece of paper and your calculation manually, is the mistakes that you may make along the way. All right, but if you are using a machines, okay, you can always put in if let's say you need to program certain algorithm, okay, as long as your algorithm is correct, the looping type is just the same. Okay, so it does not, it, it has a little bit of less problem if you are using a machine. But right now we are trying to see how to calculate, okay, the simplex method by using our mind and our piece of paper, and also our pens. All right. So, first of all, okay, you need to convert that particular problem into a standard form. Okay, standard form meaning that the first thing that you need to identify is on the constraint part. Okay, the constraint part, you have to identify whether your constraint part is it having a form of less than, or is it having a form of greater than. Okay, so this makes change this one change a lot on your table. Okay, so if you have a less than form, we call that a slack variables. If you have greater than, we call that a surplus variables. Okay, so the difference is that if you have a slack variables, your transformation of your constraint will become something like this. Okay, whereas if you have a surplus variable, then your transformation of your constraint would become that would become like this. Okay, the difference is that on the select variable, your surplus now, sorry, your slack now becomes plus s, no matter how many s you have, and then your greater than, your surplus variable now become negative s. Okay, but the solution is exactly the same. The idea is that on this, okay, the concept is this one, this plus s representing the resource unused, and the minus s representing the over satisfy variable. Okay, so that's the only problem, that's the only difference between those two, but the solution is exactly the same. Okay, how to solve this? All right, so the first step do you need to do is, I always remind you to keep track of your table form. Okay, there are reasons for that. All right, because you don't get caught up with the issue in hand. Okay, so on the left hand side, I put again all the variable information that we need to consider. Okay, I put in red all the numbers. Okay, numbers is actually the coefficient for all your variables involved. Okay, you have, for example, 4 hours of labor from the carpentry departments, and then 2 hours from the finishing departments, and so on. All the details on the right hand side, red, left hand side, with the red color. Red color sentence, that's all that you need to consider. Okay, and then you transfer all the red color on your left hand side into your table form. Okay, in this case, I can simply say that my resources are just this. I have a table, I have a chair, and then I have the final constraint that I need to consider. Okay, in the carpentry unit, my constraint would be at most 240, and my finishing hour would be at most 100. Okay, and my unit profit, given for table, is per unit. I'm able to get 70 ringgit out of that. Produce table, and then for chair 50 ringgit. Okay, so once I get this in place, okay, I put this into this is actually the objective function with all the constraints, okay, that you have. Okay, it's a little bit messy over here. All right, so these are the constraints. So what's the difference between simplex method and the previous linear programming that we have? Okay, where we have the graphical issues, where you need to utilize your graph, meaning that all your constraint you put it into a linear line. All right, and then you find the feasible solutions from the linear lines. This one, no need to do that at all. Okay, the only thing you need to introduce your s, the slack or the surplus variables. Okay, so how to do just that? Okay, I put on the left hand side over here, left hand side bottom, just in case you get forget about our original issues. Okay, these are the objective function, the constraints. Okay, non-negative condition you know already, doesn't matter. Okay, and then this is the changing variables of this. Okay, your first constraint now, okay, becomes this. See, I introduce s over here, and then your second constraint now become this. I introduce S over here. But you have to remember, okay, the first constraint you put S1, the second constraint you put S2, because these two different select variable is not the same, right? S1 is for your carpentry constraint, whereas your S2 is for your finishing constraint. It's not the same. Okay, and then how can we incorporate these two different select function into one? That is when you transform this into this, meaning that in all your constraint, you consider both your select variables, meaning that you put S1 over here the same, but at the same time you introduce your S2. But since your S2 now actually does not concern with your carpentry constraint, right? But then once you involve that into a first constraint, you put zero over there. It does not, it does not affect your first constraint. Okay, but by the end of the day, you want it to be included into your constraint. So that's why you put that. Doesn't matter as well. So this one is also the same. You put 0 as one additional, okay, for your second constraint, okay, and the rest will be the same. Now we move on to the objective function. Objective function, our early objective function would be here. Oh, sorry. Okay, our early objective function is here. And then once we introduce the constraint, this is the objective function that we have. Okay, we have 0 S1 plus 0 S2. Actually, it does not change anything, right? P1. But we introduce it just for the sake of we want to put that into the same table that we have, meaning that all the table we have all the S, all the X together. Okay, so that's why we have this. And then once you know all this is the same, and then you know all your constraint, you have the value. Okay, the value for your right hand side, meaning that the limiting value. For example, the first constraint you have 240, the second constraint you have 100. So it will be just right if you transform it a little bit so that you have this particular value over here. And how to transform this into a particular value on your right hand side, you can just use your linear algebra knowledge. Okay, your prior knowledge on this, meaning that on your right hand side, all of this you put on your left hand side, and then you can get zero just as it is. Okay, that's why you have negative here, negative here, negative here, and negative here, for the sake of you transfer your right hand side materials on the first equation here into your left hand side. All right, so this one is clear. Okay, now our main intention again is get this into a table. Okay, initial tableau. Okay, we call that. That is a simplex methods, right? So once you have this, okay, you notice I have x1, x1, x1. I have x2, x2, x2. I also have s1, 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 s2, 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 and also the previous one plus this p. Okay, so how to transform it into a table? This is your final table. Okay, this is your final table, meaning that you look at the basic variable here, just put S1, S2, and also P. Okay, representing the first. For example, S1 is for your carpentry, and then S2 is for your finishing. Okay, that one is clear. And then all your variables at the on top of it would be all the one that you consider. But do not also forget to include your P over here as well. Okay, and then up until your right hand side is over there. Okay, so you transform. I put it on the left hand side bottom here. This is the previous slide that you have. So you only transform the coefficient into the table. 4 x1 for 4, 3 x2 for 3, 1 s1 for 1, 0, okay, for s2, no P available here, and the right hand side would be 240. So the same thing, you do the same as well. Okay, now this is getting interesting. All right, so once you have this as your first step, your main intention is you need to refresh to your 7 steps in the previous slides. Okay, your 7 step in the previous slide, okay, mentioned that when you identify all your coefficient into a augmented matrix. Okay, augmented matrix actually is just the meaning of this. You have 6 by 3. All right, 6 by 3 matrix. Okay, and all the coefficient inside your matrix over here. So this table is just your metric, and then you need to identify, okay, the non-negative value on your last row. Okay, on your last row you have non-negative value, and then you need to see from this non-negative value which value has the bigger value. All right, so that is what we start to do. Okay, so uh, okay, this is what we start to do. Okay, if you look at this one, once you have negative 70, this one is the value that you need to consider, because it has the most negative on your final column. Okay, and then if you have this most negative value, you straight away say there's, oh, this is my private column. All right, so what's the significance of my private column? What's the significance of this value? Because I want to identify this particular column. Remember, column versus row, we are talking about column only. Okay, so this particular column is the one that I want to tweaks. Okay, I want to tweak. So how can I tweak this particular pivot column? Okay, now we move next. Blah blah blah. Okay, so once I have this particular pivot column, the first thing that I need to tweak is I need to do this operation. Okay, how to get this value on this operation? Okay, meaning that I have the value over here. Okay, 100. Okay, I need to divide with my pivot column value over here. Okay, so meaning that you have 100 over 2, so I have 50. And then the next column, 240, the right hand side value, I divide with my pivot column elements, which is 4. Okay, the red color the same, so you couldn't see it. Okay, so 240 over 4 would be 60. Okay, so you can imagine if, let's say, you have a lot small constraint, you do the same thing for each of your rows, and then finally, once you get all the answer on your right, the very right hand side over here, what you need to do is from 60 and 50, you need to choose the smallest value. Okay, in this case, my smallest value is 50, so I choose number 2 over here. Okay, that's why my number 2 now in a green color. Okay, so that one is clear, right? Okay, that one is clear. So at the same time, do not forget, we are talking about pivot column x1. Okay, and then we have pivot column that is correspond to this particular tweaks problems. Okay, we have S2. So once we start doing this, you change your x1 now with s2 now in this case. All right. So meaning that s s1 s2 over here. Okay, I put a little bit so that you get it. Okay, s2 over here, you change with your x1 at the same time. Okay, so this is what you have now. Okay, so this is what you have on your right hand side now. uh, Sorry, on your left hand side now becomes x1 over here, but your s1 and also your p still the same, right? So this is what you get from the previous value. Okay, once you identify this, oh sorry, I didn't copy paste there. Okay, once you identify number 2 over here, your main intention is you need to make sure that this one becomes one unit value. Okay, if you remember your linear algebra, it's just the same. It's like you are eliminating the row by I forgot the name of that method, but by the end of the day, you need to make sure that your value will become 111, right? Like an identity, for example. So you eliminate row slowly. So the same thing happened here. 2, how to eliminate, you just divide by 2, right? So the same thing happens, you cannot divide by 2 only with your row, this 1, right? So you need to divide 2 with the rest of your row. Okay, so that's why in this case, just for us to not forget what we are doing, currently we divide every element in your row 2 with 2. Okay, that's why we have R2. Okay, so 2 over 2 is 1, and then the rest will follow. This one, 1 over 2 is half, and so on. Okay, up until your right hand side. Okay, do not forget your right hand side. Because previously, for example, here you have 100 on your right hand side. Once you divide with 2, this is what you get, 50. Okay, so this one is clear as well. And then what's next? Okay, so always remember again your linear algebra. You're going to eliminate your row and your column strategically. Okay, so okay, I put on my left hand side at the bottom the previous slide so that you don't get that confused at all. Okay, so the same thing happens as in your linear algebra. I'm going to make sure that all my elements in the column that representing with my 1 over here to be 0. This one 0, this one also 0. Okay, so how to do just that? Okay, I show you one example on the row. Okay, on row S1. All right, so row S1. Okay, previously this one, this row. Okay, I'm going to change this row with this row. Okay, so we start firstly at the not bottom, at the upper part of 1. Okay, let's say you look at 4. How to make sure that your 4 now becomes 0? Okay, it should become, you should minus 4, you multiply minus 4 with your second column, sorry, second row. Okay, and then you plus with your first row, correct? For example, on your second row, you have negative 4. Okay, this one is your second row. Okay. Okay, on your second second column. Okay, second column after your S1. Okay, so you have negative 4. Your R2 would be 1 plus your the previous one at the bottom left. Okay, 4. So that one you have negative 4 plus 4 just equal to 0. Okay, that one is clear. And then, okay, refer back to your bottom, okay, so that you don't get confused. And then we start to look at the third uh, column, okay, after S1, 4, and then 3. We are looking at 3. Okay, we are looking at 3. So basically you have negative 4, and then your R2 is half. Okay, your R2 is half, and then you plus 3 over here. This one you get 1. Okay, so this is your answer, 1. Okay, and then for your fourth column, okay, on your fourth column you have, okay, negative 4, and then your R2 should be 0 plus 1. Okay, so you will have 1. That's why you get 1 over here. Okay, and then the rest, blah blah blah, you get that. All right, you get you do the same thing also for your negative 2, for your 0, and for your 40. Okay, based from your previous value in this table. All right, so that one is clear as well, right? So the same thing you do for your column. You do for your column, the final column over here. Okay, that's why you have 0 again, negative 15, 0, 35, 1, and also the final one, 3500. Okay, how to, okay, this one is not perfect yet, okay, because there are lots more numbers over here, and then there's still negative value on your final row column. Okay, the negative value on your final columns. All right, so it is still not finished yet. But if let's say you want to understand what is it that you get over here, right? Okay, so you can simply say this is the explanation of what you get. Okay, if let's say, okay, you know your x1 is a table. Okay, x1 is a table, x2 is a chair. So from this table you can safely say that, okay, if let's say you produce 50 tables, Then the unused carpentry hours are reduced by 200. Okay, reduced by 200, meaning that earlier table you have 240 over here, but in this current table you have 40. So meaning that, oh, it reduced by 200 because you just only have 40 hours right now. And then the profit is here. By producing 50 tables, okay, your profit changed from zero, okay, meaning that over here into 3500. But is this the right way to move? Okay, we still have, as I said, incomplete version of my simplex tableau, okay, or my simplex table, because my column, okay, column, yes. On my final column I still have -5. So what to do next? All right, what to do next? Now, this is what I said, that the repetition of this simplex method, as long as you do it carefully, and then you know how to solve that, then that would be fine. You do exactly as what you did on the previous examples. All right, not previous example, previous steps. Okay, so in this case, for example, this one I can go quite fast, quick. So this is now your pivot column. Okay, this is your most negative value, and then the same thing happens here. This one is negative point, yeah, 0.5. Oh, sorry, 0.5. So basically the same thing happens. You find your value over here first, and then once you get all the value, you divide your right hand side with the pivot columns element that correspond to your values for your right hand side. And then once you get the value over here, you identify the smaller value from 40 over 40 versus 100. 40 is the smallest value, so you identify your one now becomes the element that you want to consider. And once you have one as your pivot, the rest is just zero. The rest meaning that the elements within your column, all right, not your row, okay, not your row, your column, exactly as your linear algebra. Okay, so the same thing happens. So you just do all the same together. Now in this case, your table form is just nicely put 100. And then once you identify that, do exactly the same thing over here. Slowly, one by one, change a little bit there and then for your row index in that case. And don't forget to also change your basic variables now. Okay, instead of S1 just now, you change that into X2. Sorry, at that particular corresponding column. Okay, so once you identify this, okay, now after this, okay, this is your 4100, right? And then all these p value 0, 0, 15, 5, and 1. Okay, once you get this, is it enough already? Okay, that is the question. All right, so if that's the case, you look back at this last row. Okay, the last row. Okay, in this case, your last row, okay, I put your value, previous value there. In this case, your last row over here, now it does not contain any non-negative numbers. Okay, so once it does not have any non-negative number, you look back at your previous steps 1 until 7, and you can see, oh, there's no negative numbers. You cannot do anything anymore, meaning that, oh, now this is the solutions, okay, that I want. Okay, meaning that this solution now becomes a maximum value for my p. Okay, so how to what to say, how to translate this into a decision. Okay, so how to translate this table in a decision, you can refer back to this simplification. Okay, meaning that if let's say, since my profit now is the maximum profit, so I can safely say I need to produce 40 chairs over here for my X1, and I need to produce 30 chairs from 30 tables for my chair 30 chair just now is for your X2. And then tables, you need to produce 30 tables to get to the maximum profit value of 4100. Because on the previous table, for example, earlier, your tables earlier you have 50, right? But once you increase a little bit on your X1, X1, X2, sorry, X2 chairs, you put your X chair now becomes 40. Now your tables reduce from 50 to 30. So by having the reduced table and by getting your chair into 40, your maximum profit now becomes 4100. So this is the most value that you can get by having all the constraint that you need. Okay, so I think that's it. Okay, so I will conclude. This is the one thing that I said earlier just now. You can say that your X1, your table now is 30. You produce your chairs now is 40, and then by producing your 30 tables and 40 chairs, your profit now will become the most profit that you are able to get, 4100, assuming that your constraint does not change. Okay, so if let's say you want, okay, this one is another story. If let's say you want to increase or decrease certain constraint, okay, you are still able to do that. How? By using your sensitivity analysis, as how we earlier touched upon. All right, so I think that's about it. So this is the simplex method. I hope you enjoy the video, and I hope you get the overall general idea of how are you able to get benefit of the linear programming problems. Okay, because this linear programming problem, it's very versatile. All right, it can go into lots of different productions or different problems. Okay, as long as you need to improve certain things, you need to find the optimal solutions, for example, and as long as you have the constraint that you need to consider, you can always do this problem. The only problem that you are not able to use the simplex method or simple algorithm linear programming, for example, is when your model is not deterministic. That is the main issue. Okay, if let's say you have a model that is not deterministic, if you have a continuous model, there are other ways for you to consider. That's when different type of methods need to be done. Okay, that's when you start to have we have an optimal theory. Okay, that's a little bit extensive, and it's a little bit a quite difficult concept, but there are people working on it, and the progress is keep coming on, because whatever it is, optimization is a very very extensive theory, and a very worth topic for you to study. All right, so I hope you enjoy this video again, and I'll see you guys in the next lesson.